appropriately. So higher order functions. So far, when on Thursday when we showed you that list of all of the data types, right? We've more or less at this point covered all of the primitives, right? The strings, the booleans, and numbers. We've kind of covered all of those. We've seen how those are used, how those are passed back and forth between different things. And then when we look at the complex data types, there was the three big ones are arrays, objects, and functions, right? So we've done 2 days on arrays, we've done 2 days on objects, and now we can do two sessions, if you will, on functions. So we're going to talk about a few things. Why functions are special, how do we use functions within other functions, and then something called for each. And then we'll build on top of that too. I know on Thursday someone asked, are we going to cover things like filter and map? And we will. We'll probably do it like in this afternoon session. But I'll probably talk more about it as opposed to kind of do a workshop on it, just because, like I said, those are kind of nice to knows, but they're not fundamental to passing the interview, or rather you can mirror their effects with a for loop as opposed to kind of learning something new just for that. And you'll definitely learn them in the full-time immersive. It's just for us, time is a pretty big gating factor here. Okay, why functions are special? Surprise, they're not. Functions are just like every other data type in JavaScript, right? In fact, we lump them under complex data types, which means that the way that we use objects, the way we use arrays, we can also use functions. People tend to think functions are different, but for the purposes of this session and the afternoon session, think of them as almost just like objects that you can invoke, right? They're objects that you can use. And if they're objects that you can use, therefore you also have the option of not using them, right? So in that case, like in the cases in which functions are not being used, you can treat them just like objects. You can treat them just like any other data types. The reason why we're talking about functions here is because whereas before we were really used to like here we're doing this. We're actually really used to creating an array and storing an array of, in this case it should be string values supposed to turn out, but in this case we're just adding a bunch of strings to an array, right? And we're pretty comfortable with that. Well, if I tell you that functions are just like objects, they're just like any other data types in terms of kind of how they're being passed, how they're being stored, we can also do something like this, right? We can actually add a function to an array, right? So now we have an array rather than of three strings, we have it of three functions. Notice how this function here, how it shows up in square brackets. That's more like a tendency of console log to print out functions in that way. This does not mean that this is like a mini array. So this is just more like a visual thing to keep in the back of mind. This is just the outer brackets are indeed the brackets of an array, and this amazing array we created on line 3 there. But each function is just a function. We just happen to print it out that way. So don't let that trip you up. But yeah, we create an array of 3 functions, right? The way we do it for 3 strings, 3 numbers, we can now do it for 3 functions. And this is a theme that I'll talk about over and over again, right? Treat functions just like any other data type, with of course one exception. Okay. If we go back to earlier when we created this, so before we did a push, now we just create it like I created let array equals 1, 2, 3. Here we just create an array, right? And in this case on line 4 there, I defined this function called happy function. Notice how on line 8 I'm just putting happy function in the array. So once again, I have my array of 3 functions. The exception to what I talked about earlier in terms of us treating functions like anything else is the one thing you can do with functions that you can't do with any other data types really is you can invoke functions, right? We can use functions. How do we invoke functions? Yeah, not the brackets, the parentheses. Yeah, and it's something that we want to just be visually kind of careful about because those things are very different. They mean different things. But invoking a function requires us to use the open and close parentheses. All right, and I'm going to say this now, and I'm sure you'll get tripped up on this during the workshop. A function can either be a variable or it can be invoked. Okay, if it's invoked, it has to have an open and closed parentheses after it. If I see a function variable like I do here, happy function, without the open and close parentheses, it means this function is not being invoked. If this does have an open and closed parentheses after it, then it means that function is being invoked. All right. So over the course of this morning and this afternoon, we're going to look at functions in a lot of different contexts. And at each context, just be very, very careful. Snowing or raining? Anywho, just be very, very careful in the back of your mind to just note that is this function being invoked or not? Okay. If a function is being invoked, it means something very different than when the function is not being invoked. So here, once we create our function, our array of 3 functions, we can go through it, right? And on lines 10 through 13 is just like any other for loop that we've seen, right? We start at index equals 0. We go through the entire length of the array, and at each element, we create this variable called element. We set it equal to amazing array, this particular thing of amazing array, and then we invoke it, right? Notice how amazing array index of I is a function, right? So element now becomes a function. And in fact, when we talk about kind of pass by reference versus pass by value, it's not just a copy of that function, it is that function, right? It's the same reference in memory. So think of it that way, right? Now we now have this variable called element, we have this variable called happy function. They're both pointing to the same function, so when I invoke element there on line 12, I'm essentially just invoking happy function. Cool? Right? So pretty standard, right? In terms of if we apply the pass by reference versus pass by value to the array here. Yes,
so
Sarah?
In the array, you wouldn't have the parentheses then?
Yes. We'll talk about why the parentheses, like,
okay.
In one of the later examples, you'll see what that means. Okay, so yeah, so if we're kind of going on the theme that hey, functions are just like objects, or just like primitives, or just like data values, like anything else. Well, one of the things we also do, one of the things we also do is we also pass these values into functions, right? We do this all the time. We pass in an array to a function. We pass a boolean to a function. Well, guess what? We can also pass a function into a function, right? So here, the function logs a type, expects something called value, and it just console logs out what the type of that value is. On line 7, we're passing in a string, so the type of is going to be a string. Nothing too fancy here. But now if we pass in a function like we are here, and I run it, I run this function, what I'm going to get is I'm going to get a function, right? This, at the very least, just kind of proves this idea that, hey, we can at least pass functions into other functions and we'll recognize it, right? On lines 10 through 12, we're creating this function called happy function. On line 14, we're passing happy function into logs a type, right? And logs a type just takes this value. So basically here we have a variable called value with a variable called happy function. They're both pointing to this underlying function. And so when I say type of value, it's the same as saying type of this function, which is a function, right? And that's what we get up here. Any questions so far? All good? All right. Cool. All right. So now, here's the part where here's the part where I think the open and close parentheses, or rather making sure we know without invoking it, makes a lot more of a difference, right? When I look at this piece of code, right, I think I said before, like for me, like I tend to jump past the definitions first because I kind of want to see at what point does this code start invoking, right? So line 3 through 5 creates a function, but I don't need to look at it just yet because I might never need to use it, right? Line 7 through 9 do the same thing. Line 11 is the first time where I see a function being called or some process being executed. And I know we're calling a function because guess what? Calls a function is followed by an open parentheses and a close parentheses. Yeah, there's some text in the middle because we're passing in different arguments, but once again, this tells me that I'm invoking an argument. And I'm invoking calls a function up here on line 3. And I'm passing in this thing called happy function, which is another function. Okay. When I pass in happy function into another function, notice how between here and here, basically before line 4, at no point is happy function ever being executed, right? I never see happy function followed by an open and close parentheses, right? Up until line 4, it never gets executed. On line 4, is where we actually run the open and close parentheses. So when we actually run happy function, what happens is we console log out I am happy, right? That's why when we look at our printout, we see I am happy only executing once, right? It's only printing out once. It's only printing out once because that code is only being, or that function is only being invoked or only being executed or run once. And that execution happens on line 4. Ignore him. Does this make sense to folks? Right? If I didn't have this open and close parentheses here, what will console log out? Nothing, right? If I didn't have this parentheses here, nothing console logs out because calls a function doesn't call any console logs, and nothing else does really either, right? The only thing that runs a console log here is this happy function. If I don't call it, console log never runs. So if I don't have that open and close parentheses there, this will just be a blank screen, right? That's one difference between the open parentheses versus not open parentheses, right? The code that the function here never runs if I don't invoke it.
David?
Yep.
So if we had a variable called happy function, like just to completely just let a happy function equals, well, I guess a string, then how would you know it's calling the function and not the variable?
Which line would happy function be on?
If you just add a variable, whichever line, I guess 10 or something, and it's called happy function.
Well, so now we're talking about scope again, right? Because remember, how do we determine where to look for a variable? We look in our own scope first, bottoms up, right? And then if it's not in our scope, we look in our parent scope to see if there's anything there too, right? If I add a happy function, let's say here on line 10, I say let happy function equals a string. When calls a function looks for a happy function, it will look in its own scope first. It will say, great, what's the most recent happy function variable? And I find it on line 10, then I use that version.
Okay.
If I define happy function on line 6, then I'm overriding on line 7. So when this calls for happy function, it will find the function first. So the order, so where we define it is actually extremely important because you always look for the latest version of that variable. Yep. Good. All right. So just gonna do a few more examples of this. So here we have two functions, says hi, says bye, whatever for now. We don't need to look at them just yet. We have a function called calls with name. And then on line 13 and 14 is kind of where we start actually executing code, right? On line 13, we invoke this function called calls with name, and we pass in two things. The first is a string called Sadie. The second is this function called says hi. Okay? Where's it here? Is says hi being invoked or not? Not yet, right? So right now, says hi could be a string, it could be a number, it could be a boolean, it could be anything. It doesn't matter to us just yet because we haven't used it for any purposes just yet. Let's go to calls with name. Calls with name takes in two arguments. The first argument is going to be a name. The second argument is something called a callback. And callback is just another word for a function that's being passed into another function. You could use that term if you want. You could not use it, up to you. But when you see the word callback function, it just means this is a function that's being passed into another function, presumably to be used by that other function. Okay? So there's something called a name. We have a variable called callback. Okay? And on line 10, kind of interesting. I don't think we've seen this pattern before. We invoke callback and we pass a name. And so if I kind of zoom out really quick and look at what this function is doing, what this function is saying is this: hey, give me something called name, give me something called callback, and I'm going to invoke callback, and I'm going to pass in as an argument to that function the first thing you gave me. Cool? So when I look at what that means is, well, callback is pointing to the says hi function. Says hi expects a name, and it's going to console log out hi, comma, name, right? Here, notice the open and close parentheses. I am actually invoking callback, and if callback is says hi, then this means I am actually invoking says hi. And I'm passing into it this name, and the name I'm being passed in is Sadie. So when I run line 13, says hi actually runs. It says console.log hi, comma, Sadie. That's where this comes from. This is coming from line 13, right? We invoke calls with name. We pass in two things, one of which is a function. And on line 10, we're actually invoking that function. Okay? Passing in that function does not mean that we run that function. This callback followed by open and close parentheses, that means we're actually running that function. And if that function says hi, and we're passing in name into it, this expects something. We also have to call the name, and we're constantly logging out hi, comma, name. Okay? And so the converse of this, or rather the I guess it's not really converse, but I guess the additional application of this would be if I pass in Sadie and I pass in says bye, guess what? My name is going to be Sadie. My callback is now going to be, it's going to refer to this says bye function. The says bye function also expects a name, and it logs out hi or bye, comma, name. So here on line 10, when I invoke callback after I invoke line 14, callback is now pointing to says bye, and not only is this callback saying says bye, callback is actually being run. So says bye is actually being run, and that's where we get bye Sadie from here. Any questions? Please tell me if any of this is confusing, because if this doesn't make sense, the next couple slides won't make sense. Right? Yeah, Andre?
Is callback like a reserved word, or is just like...
No, it's not a reserved word. It's just it's just colloquially people call it a callback function. We can name that variable anything we want, and it's totally fine. Okay. Okay, so now we're kind of building on top of this idea, right? Lines 1 through 3, 5 through 7, we're creating functions. Okay, cool. Line 9, we're creating this variable called result, right? And we're saying, hey, I'm going to give you a value. What's that value? I don't know yet. Let's figure it out. So let's focus on the right-hand side of this line 9 here, right? Calls with hello. Okay, calls with hello. Is that a function? Yeah, it is. And it kind of has to be a function, right? Because we're invoking it. And so in JavaScript, what JavaScript is going to do is JavaScript is going to try invoking it. And if it can't, it'll say, hey, this is not a function. It'll throw an error at you, and your code will stop, right? So by definition, calls with hello has to be a function. And what does calls with hello do? Calls with hello, it takes in something called func, and it returns back that func invoked, okay? We'll talk about what this return means in just a second here. But just for now, if we follow through the line of code, we say calls with hello, and we pass in add world, which is another function. Okay? At this point, is add world being invoked or not? It calls with hello being invoked. Right? Calls with hello is being invoked because we see calls with hello, open parentheses, close parentheses. Add world is not being invoked, right? No open and close parentheses yet. When we go into calls with hello, add world, this variable add world is pointing to the same function as func, right? These two are now pointing to the same exact function. Okay? And on line 6, if we ignore the return for now, what we're actually doing is we're actually invoking func. So on line 6 is where we're actually invoking add world. Okay? Now, we're passing into add world this string called hello, and it basically returns back hello world, right? Add world doesn't console log anything. It returns hello world. And what does return, what does a return function return that thing to? To the machine. Or more specifically, it returns to wherever that function was being called, right? So here, when this returns hello world, this becomes hello world, right? And then calls with hello says, hey, return whatever this is going to be. Well, if this is going to be hello world, then calls with hello is also going to return back hello world. And so all of this on line 9 there, that becomes the string hello world, and that's what we assign to result. So when you console log out result, we get hello world. Add world passes this hello world to calls with hello. Hello world or calls with hello passes this hello world to here, and that's what gets assigned here. Okay? Return is super critical because, and this is kind of the crux of why it's important to know whether or not function is being invoked or not. A function, if it's not being invoked, is just like a variable. You can pass it back and forth, nothing happens, right? But if a function is being invoked, then that function is no longer that function. That function is what now? That function now becomes the return value of that function. So I'm gonna probably be a little bit anal about this because this is like super critical, right? If I have a function that says, it takes in, I'll call it David. David takes in nothing and just returns back the number 4 or number 5. Okay. If I do console.logout David plus 4, what do I get?
5 plus 4. Oh.
I get back literally something called function 4, and this is kind of a little bit janky, but what it's doing is actually saying, well, David's definitely not a number, because what's David? David's a function. And so when I try to add these two things, it looks like what it's doing is it's turning my function into a literal string, turning the 4 into a string, just adding it to the end of it, right? If I ever wanted to do the actual operation of 5 plus 4, I need to do what? I need to invoke David, because once I invoke David, David now becomes the number 5, because my function, once you invoke it, it returns back 5. And so now I get 9 there on line whatever on this line here. Everyone can see it, right?
Yeah.
Right. So this is why it's really, really critical to know whether or not a function is being invoked or not, right? David and David invoked are fundamentally different things. Those are not interchangeable. You can't just use one in one place and use the other one and think that you'll get the same result, right? These two are very different. So this is what Andre meant when he said David is a function. David invoked becomes whatever this function returns. Do you see that? Right? And remember, every JavaScript function always returns something. If I don't put a return value in there, what does it return?
Nothing.
Well, that's not very helpful. All right, comment on this. Undefined. Remember we talked about this on one of our first early classes, right? Every function in JavaScript returns something. If you don't tell it what to return, it will by default return undefined, right? This also means that, guess what? David invoked will always have a value, right? At the baseline, the value is going to be undefined, unless we somehow, in this data function, we say, hey, return something else instead. Return a number, return a boolean, return a string, whatever it is. Return something else instead. But David invoked will always give you back a value. At the very minimum, that value is going to be undefined. So this is just something that just, if you want to write this down somewhere, just remember, a function and a function invoked are very different. Okay? And a function invoked becomes whatever that function returns. So we go back to this slide now. I think it's on the CS Saturday. It might be on the 25th. Yeah, it might be on the 25th floor tonight.
Thank you so much. Sorry.
Yeah, you're fine. So just realize that func and func invoked, very different. Okay? Here we're returning invoking func. We're not returning func. Okay? So this is imperative that we figure out what func actually returns before we return it back. If we didn't invoke func and we just return func, then we're returning a function. But once we invoke func, now we're saying, hey, what does this function return? It returns back a string. So now we're returning back a string. So at every single step, always be very, very clear to yourself and be very clear at every step, what is the code actually doing here, right? If it's invoking something, then you need to figure out what that value actually evaluates to before you take on the next step. You can't just kind of, like, if nothing's being invoked, you say, oh, it just passes back and forth, we'll use it some point later on, right? If a function is actually being invoked, you really need to be clear on what that function is returning before you take the next step with it. If it's a number, you can do something very different with it than if it's a string or a function. Your question, sir?
So if on line 6 it was not invoked, then we would just return add well, like function add well.
Yep, exactly. Okay. So here, this one's probably a little bit simpler to understand, right? So on line 7, we actually create this array with 4 names. We call it group. And all we're really doing is we're executing the say to all function. We're invoking it, right? See the say to all, open followed by close parentheses. We're passing to it 2 things. We're passing it the array we just created, and we're passing this function called say hello with name. Okay? So I jumped from line 13, I jumped to line 1, because that's where say to all is. And all say to all is doing is saying is, hey, I have this names, or I expect you to give me 2 things. The first thing is called names. The second thing is called say with name func. And really, like, what I'm going to do is I'm going to loop through everything in the first argument, and I'm going to just invoke the second function, the second argument, the function you give me. I'm going to call it with every single thing in this array, right? So that's why, and what this function is saying is say with name func. Say with name func is the parameter value for this say hello with name, right? So these 2 variables are pointing to the same exact thing, right? They're both pointing to this say hello with name function. And what this function does is it takes in a name and just console log hello name exclamation mark. So what this is doing is it's just running this function on every single name in name. So when we log this out, we get hello everything, right? Notice how here we never worry about return statements because nothing's being returned, right? Actually, that's not true. We are still returning undefined every single time we call the function. But notice how we're never assigning that value anywhere, right? We never say x equals this function invoked. We're just running it, right? So the function does give back a return value, but we just kind of ignore it. We say, oh, that's nice. Like, we won't use it, right? In the same way that when we use an array.pop, you know how like we take away the last thing in the array, but then we also give back you the thing that we took away. Sometimes we don't actually care about the thing that gets back, right? We just care that you take away the last thing in the array. Same thing here, right? Here we don't really care about what you give back. We just want to make sure you actually do that thing in the code block. In this case, the console log. And yes, it is still giving me back undefined, but I just don't quite care about it at this moment. Okay, so this is so this is why, you know, when we talk about kind of passing functions back and forth, the return statement is something you always want to be very careful about. In this case, return is not an issue to us, but in a later example, it will be. Okay, so this is literally identical to the previous slide that we just saw, or the way we did it, except whereas before we created this function, right? We gave it a name and we say, you know, let or function, you know, say whatever. Let's go to the slide. So this is the previous slide. Notice how lines 9 through 11, we create this function that does this, and we call it say hello with name. And then we pass in say hello with name down here. Now we can also do something called an anonymous function, basically a function without a name, right? And we can actually just write it directly as the second argument. And we just pass in this function directly into here. This is the second argument. So say with name func is still going to refer to this function. We're just passing it in directly. This is because, like we said, functions are just like any other data types. This is synonymous if I do something like if I do, you know, a comma b, right? And I do, you know, let's return back a plus b here. This is the same as me saying, hey, let's return back 1 comma 2. I get what? Wait. Oh, never called David. That's why. Okay. Here I get 3, right? If I say let x equals 1, let y equals 2, and I console.log out. I'm just gonna copy this. x comma y. These two are identical, right? The only difference between the one on line 8 and the one on line 10 is on line 8, I happen to name these numbers first into a variable, and I pass in the variable here. Here, I just said, you know what, let's skip the variable. Let's just pass your values straight into this, right? These both are equally valid. They'll give you the same exact answer. This is what we're seeing with anonymous functions too, right? Usually what we're used to doing is saying, hey, let's create a variable name for a function, and let's set it equal to the actual function itself, right? And then we'll pass in the variable into this. An anonymous function says, you know what, let's just get rid of all the intermediary steps. Let's just pass that function directly into where we need it to go. And yeah, so here we're still taking a function that takes in name and console logs out by name exclamation mark. But here we're just writing the function and just writing it in directly as the second argument. Make sense? Yeah? No? Thumbs up, thumbs down from folks?
But isn't it easier to just, or maybe it's because I'm new at it, but it's easier to read the other one than to read this one?
Yeah, for sure. It definitely is. It definitely is. But like I said, right, like at a certain point, like you kind of get used to the syntax and you want to type less. There's also a few other use cases for anonymous functions that we probably won't talk about in this class. But for now, just kind of accept that this paradigm exists, right? Like with a number, we can say, hey, variable equals number, let's use variable, or we just say, let's use a number directly. Function, same idea. We either, hey, let variable equals function and use that variable, or we can say, let's just use this function directly. All we're doing here is saying, let's use that function directly. So this one, I won't probably go through in as much detail, but this is just saying, we on line 13 and 14 is when we're running the code. We're both running calc. Calc takes in a number, an operation, and a second number, and it basically calls that operation and passes in the first and third arguments, right? We're just calling operation func, and we're passing in num1 and num2. And once again, notice these returns, right? This doesn't actually matter now in this case what operation func is. It matters what operation func returns, right? Because we're invoking operation func. Cool? And so operation func is going to return, looks like either a number or a number. So this is going to be a number, and then calc is going to return back a number. So when we run this, we get 30 and 40, respectively. Cool? Yes? All right. And then the last thing we'll talk about is for each. Yeah, okay, whatever. Not whatever, but I'll explain all of that thing that the text kind of in the example here, right? So remember when I was talking about the for and loop for objects? It's like, oh, a for and loop goes through every single key in the object for you, right? And the purpose of it is designed so that, hey, use this when you actually want to go through every single key in the object. If you say I only want like every third key, don't use for and loop, right? It's like a tool. It's like a tool that does something that is supposed to make your life easier for a very specific instance. If you don't want to use it, don't use it. Okay. Same thing here for each. A very common kind of pattern you'll see, especially when people use arrays, is I have an array of things, and I want to execute a function on every single thing in this array. Okay, and in that case, we can mimic this easily, right? By saying, hey, let's just loop through the array, and for each element in the array, let's call a function on it. But because it is a very common use case pattern, what JavaScript did is they actually built in this thing called a for each function into all arrays. And what for each does is you call it with, or rather the array calls for each. You do array.forEach, and you pass in something called you pass in a function. And what this will do is this will go through every single element in the array, and it will pass in each element as an argument, and it will execute that function with that element for you. Okay. With a for each, a few caveats to note, right? Here we define a function that takes in, a string, right? And what we do is we print out that string all capitalized. That's great. Guess what? This function has to take in an argument, right? If it doesn't take in an argument, there is no point in calling it here, right? Or rather, sorry, let me rephrase that. This function has to be prepared to accept the first element as an argument. Because if it doesn't, for each can't work. What for each does is for each makes a lot of assumptions on your behalf. It assumes a few things. It assumes that, hey, I'm going to call this function on every single element in this array, and I'm going to assume that every single function, that every time I call this function is going to expect the element as the very first argument. So if we want to rewrite this kind of in a more kind of heavily modified, or in a more kind of homemade version. Okay. Okay. So this is what we're doing, right? If I want to, let's say if I just gave you, let's say I don't use for each, right? If I want to call the log uppercase function on every single element in the bridges array, how do I do it normally? Well, normally I would say is, okay, great. For let I equal 0, I is less than bridges dot length I plus plus. I'm going to go through, and I am going to call log uppercase on bridges index I, right? And in fact, if I call that function, I get back the same answer, right? This on line 11 is just shorthand for what I just wrote up between lines 7 through 9, right? And so the assumptions that we make here is that with a for loop, we can call a break, we can call like a return in the middle of it and kind of stop it. Here, we really don't, or I guess we could, but really like a for each would just kind of by force call on every single thing. So you can't really cut off halfway through where you really shouldn't be. And then the other thing I'm trying to say is that, like, guess what? You know how here I'm passing in this as the first element? This is kind of hard-coded into for each, right? So if my function expects the element as the second argument, then I need to either not use for each, or I need to rewrite my function so that it expects element as the first argument. Okay, so once again, this is a shorthand, but by definition, this is a convenience, but by definition, the convenience makes a lot of assumptions on your behalf. Okay. The other thing that this function, that for each also does, is it actually passes in a few other things, into the function for you too. In most cases, you might not need to use it, but what it'll actually do is it'll also pass in. Yeah. So what for each will do is for each will actually also pass in 3 arguments total to you. Okay. The first argument that passes into any function it calls will always be the element. The second argument will always be the index. And the third argument will always be the actual array itself. Now, you might not need to use any of these 3 arguments, and that's totally fine. You don't have to. Your function could expect 0 arguments, and this will still work, right? For each will try to pass in 3 things, and your function will say, great, that's nice, thanks, I'm good, I don't need anything. And that's fine. But if your function expects the element, it has to expect that element as the first argument. If it needs the index to work, then it has to expect that index as the second argument. And if it expects the array, it has to expect it as the third argument. You can't switch around the order of those arguments because for each makes that assumption. For each will say, I will call this function for you for every single element in the array, and each time I call that function, I am going to pass in those arguments in that order. Okay, so if you say I only need the index, guess what? your function better expect two things. Even if you never use the first argument, you need to expect it because that's how JavaScript calls it for you. Or sorry, that's how for each calls it for you. Yep. So this is just basically kind of reinforcing the idea, right? Like, hey, if my function only has one argument, it's going to be the element. If it has two arguments, it's going to be the element and the index, right? Like, I need to be comfortable with this argument order if I use for each. If I say, hey, I want my function to take in different arguments in different order, don't use for each. Okay. So yeah, so that was functions. And I guess in my experience, like this workshop tends to be pretty hard because we're dealing with a lot of things here, especially this idea that like now we're being extremely kind of stringent upon, hey, when do I use returns and when do I invoke functions, right? Those are things that we've kind of gotten away with before because for the most part, we've only had one function, we write it and we invoke it, right? Now we have multiple functions that we're writing. In some cases, we're invoking it. In other cases, we're not. And in each instance, we need to be very careful about what we're returning. So are there any questions on any of the slides that I've gone over that we want to talk about as a group before I kind of let you start work on the workshops? Yeah, Sophie?
Just to sum up, so for each is expecting like the second argument is index, and which one is the third?
Yep. So yeah, so I think I did a poor job of explaining this part. For each expects a function.
Yeah.
That's it, right? And remember how log with index not being invoked, right?
Yeah.
This is just a variable here. We know it's a function because it's for each, but this could also be a string, a number, whatever you want with it, right? The function that being passed to it has to expect, if it expects any arguments, the first argument has to be the element, the second argument has to be the index, and the third argument has to be the array. Right? And documentation will be your best friend here. Like, if you ever forget that, like, it's a very quick look up. Bless you. Wow. Maps and filters are also very similar, and we'll talk about them in the afternoon session. But they follow a very similar paradigm where they expect a function and they expect a certain kind of level of assumption about the arguments and the orders in which you want to execute things in. But yeah, so for each just expects a function that you give it. The function that you give it has to expect the arguments in a certain order.
Thanks.
Yeah. Any other questions? All right. Do you guys want to do the first workshop problem together? Yeah. Okay. Great. Let's do that. Not this. Not this. Okay. Oops. All right, let me just open up the workshop, and then let's go to the first problem together. Okay, so the first problem, it's a problem called function logger. If I go to the README, let's see what it says. Write a function logger that accepts a function to run and an argument to pass to that function. Your function logger should log the message function starting, run the function, log function complete, and then return the result of the function call. Okay. Note that the tests will check that the correct value is returned. They do not check if you log the right console log at the right time. Okay, that's fair. So I'm just going to do this in REPL. I'll share with you all a little bit. But I'll break this up into steps. Step 1, write a function that takes in a function and an argument. Okay. Step 2, log message before running function. I'll say callback function. Run callback function with argument. Step 4 is to log message after running callback function. And then step 5 is return whatever the callback function returned. Okay? So this is like my paraphrasing of the instructions, and hopefully this makes it a little bit easier for us to write. So step 1, write a function that takes in a callback function and an argument. So I think this is called function logger. It takes in back, I'll say argument, and I'll call this callback function. That's it. That's step 1, right? I wrote a function called function logger that takes in a callback function and an argument. Cool? That's all step 1 is. Step 2 is log message before running the callback function. Okay, so let's just write a console logout here that says console.logout about to run. Or actually, let me check to see what the problem wants. Actually, so if I look at the test, it looks like it expects function logger to take in the callback function first and then the argument. So let me just go back here and reverse the order of these two things here. And then it logs in a message. What does it want it to log off? Function starting. Okay, and that's my step 2. Everyone good? Okay, my step 3 then. I just slacked out the repo in case anyone wants to follow along. My step 3 says run callback function with argument. So here I'm just saying callback function and I pass an argument, right? I'm running the callback function because it's callback function open parentheses, close parentheses, and I'm passing it in the argument that was passed in to my function logger function, right? So that was my step 3. Step 4 says log message after running callback function, and the message it wants me to run is function complete. Function complete. Great, that's step 4. Everyone go so far? All right, step 5 is return whatever the callback function returned. Well, so here's my little predicament, right? The instruction says to only execute the callback function once. So one thing I could do is I could have done is I could say, hey, let's return and let's call this function and return it back. But now I'm kind of not following the instructions because what am I doing here? I'm actually invoking the callback function twice, once on line 11 and once on line 15, right? The instructions kind of insinuate that I should only be calling the callback function once. And so in that case, then, how do I figure out what the callback function returned? Well, right now the callback function is returning something to me. I just kind of ignore it, right? This is kind of like calling .pop, right? Like the function itself is running, but I never really capture what it's returning. And so if I want to capture what it's returning, all I have to do is actually capture it in a variable. I'll say, let return value equal this. And now not only am I running the function with the argument, I'm taking whatever this function returns and I'm capturing it here in this function called, or in this variable called return value. So now on line 15, all I have to do is return value, and I've now kind of completed step 5, which is return whatever the callback function returned. Make sense, everyone? So now if I take this function here, I copy it, I put it in here. This should pass the specs. Make sure, did I run it? Great. All right, so any questions on this problem? Never any questions.